In Carbon Inequality, Chancel and Piketty present estimates of carbon dioxide equivalent emissions per capita for different income groups from about 90% of countries. The authors show estimates for regional shares in 2015 global emissions, regional shares in cumulative emissions, trends in inequality of emissions, and present several estimates of the cost of a global adaptation fund if targeted at above average emitters or top decile or percentile emitters. Their figure 3 shows the estimates for global emissions by region by year. It shows that emissions were initially concentrated in the European Union and North America. It shows exponential growth in global emissions and an increasing share of emissions in other regions over time. Their figure 2b shows shares in cumulative emissions since the Industrial Revolution and reveals the changing distribution of global emissions more clearly. Figure 4 shows the evolution of carbon dioxide equivalent emissions per capita by region. It both illustrates the high emissions per person in North America and the strong growth in emissions in China. Carbon equivalent emissions per capita are based on income estimates, where Chancel and Piketty motivate that income or consumption levels remains the main driver explaining variations in the total carbon dioxide equivalent emissions among households and individuals, and it is the best available proxy if we want to construct a global distribution of carbon dioxide equivalent emissions with individual level emissions rather than national per capita averages as the building block. To translate income data into emissions data, Chancel and Piketty use the median estimate for emissions elasticity, where they explain several studies provide estimates for carbon dioxide equivalent emissions or energy to consumption expenditure elasticity. That is the ratio informing on the percentage change in carbon dioxide equivalent emissions associated to a percentage change in consumption expenditure. When the carbon dioxide equivalent emissions income elasticity is 0.9, this means that a household earning or spending 10% more than its neighbor emits 9% more carbon dioxide equivalent emissions. The methodology to construct world income data builds on Lagner and Milanovic and Anand and Segal. Subsequently, Chancel and Piketty describe that the matching to emissions data is based on the macro method, is based on the work of Leontiev, known as the input-output framework extended to the environment. I will highlight only some of Chancel and Piketty their findings, but in this, would like to call your attention to their appendix figure A3. The figure shows most of the world has emissions below 3 tons per capita and shows that the emitters of more than 50 tons per year come from most parts of the world, with the largest shares from the US and China. This geographic heterogeneity among top polluters leads Chancel and Piketty to conclude that our results thus corroborate and support the key messages of Chakravarty et al., for whom all countries should contribute to climate mitigation efforts, and emerging countries in particular had to stop hiding behind their poor, given the presence of high emitters in China, India, or Brazil. On page 23, Chancel and Piketty quote Chakravarty et al. The reality that emissions from OECD countries and from countries outside of the OECD are now roughly equal, and therefore, though global atmospheric stabilization targets require the participation of developing countries. According to the authors, regardless of where people lived, individuals emitting similar amounts of carbon dioxide equivalent emissions should contribute to carbon dioxide equivalent emissions reductions in the same way. This view is in line with the opinion of most neoclassical economists and follows from that the emissions are uniformly mixing. meaning that for the effect it does not matter where the pollution was emitted. Bochholz and Sandler explain this as actions by a country to curb its greenhouse gas emissions limit the atmospheric concentration of greenhouse gases worldwide, as mixing takes place in the atmosphere. A summation aggregator applies because the cumulative atmospheric reductions of greenhouse gas stocks are the sum of all countries' reduced greenhouse gas emissions. That is, each reduced ton of greenhouse gas emissions is a perfect substitute for one another. In the third week, we will see arguments for lower carbon prices in developing countries. But let me not get too much ahead of myself. Figure 7 shows how carbon dioxide equivalent emissions change between Kyoto and Paris, or in the words of Chancel and Piketty, Figure 7 presents growth incidence curves for carbon dioxide equivalent emissions. On the x-axis, we ranked groups of synthetic individuals, 50ths, according to their per capita carbon dioxide equivalent emission level in 2013. On the y-axis, we show by how much carbon dioxide equivalent emissions grew for each of these groups between 1998 and 2013. We observe that for the first 2/50ths of the carbon dioxide equivalent emission distribution, i.e. the 4% lowest emitters, emissions actually decrease over the period by more than 10%. Their figure 8 shows the tile index has changed between Kyoto and Paris. Chancel and Piketty comment, we notice a clear reduction in between-country inequalities. The tile index was 0.46 in 1998 and falls to 0.35 in 2013. This is the rise of China effect and other BRIC countries. But we also see a clear increase in within-country carbon dioxide equivalent emission inequalities. The within-country component of the tile index moves from 0.29 to 0.35. What is striking here is that the two lines of figure 8 cross each other in 2013. Let me highlight a couple of more findings from Chancel and Piketty. If we zoom into the very bottom of the distribution of greenhouse gas emitters, we find the bottom decile of African and Latino American least developed countries, Honduras, Mozambique, Rwanda, Malawi, and Zambia. Emission levels among these populations are extremely low, about 50 times below world average. Let us now turn to the other end of the distribution of emitters and focus on the 5 highest emitting groups in the world. At the top of the world carbon dioxide equivalent emissions distribution lie, unsurprisingly, top 1% Americans, Luxembourgers, Saudis, and Canadians. These groups are comprised of individuals emitting more than 200 tons carbon dioxide equivalent per year and per person. Our figures go as high as 320 tons per year per individual for top 1% Americans, i.e. about 50 times world average and 2,500 times the lowest carbon dioxide equivalent emitters groups presented above. The picture below is of a migrant caravan of about 2,000 people walking through Mexico from south to north to enter the US. Many come from Honduras, where many have seen their homes destroyed during the past hurricane season. The paper also presents an exercise on the distribution of cost for a climate adaptation fund of 150 billion euros. Noteworthy was the scenario where contribution to this fund was restricted to the decile of highest emitters. According to the author's calculations, such a tax would amount to about 1% of their income.